Good day, ladies and gentlemen. You are highly welcome to Shito's Mathematics Coaching Program. Before the commencement of today's lecture, I urge every one of you should kindly subscribe to my YouTube channel. Click on the subscribe button. Hit on the bell to get the notifications anytime I drop my new videos. So today we are going to be looking at another aspect of partial fraction, that is with denominator. That is denominator with repeated linear factors. That is when you have a rational function having the denominator with what? With repeated linear factors. So what am I talking about? Repeated linear factor. We have something like this: f of x over g of x, and f of x is having denominator in this form: ax plus b raised to power n. You understand? So now you can see what we have at the denominator is what is linear factor, that is repeated linear factor. So what is making this one to be repeated is what? Because of the power n. I get me. So if you want to do that now, so this will actually be, that is the corresponding partial fractions of this denominator will be a over ax plus b 1, that is you have to start from 1, plus b ax plus b to 2, understand, then up to, let me say, k over ax plus b raised to power n. Therefore we are going to n. You understand? So that is how we are going to be resolving, understand, rational functions with what? With repeated linear factors. So will you be using this to solve the problem you're having on the board? You understand? So now if you are to solve this one now, so we are going to have, let's say we have, try to write this one back: 2x squared plus 1 over x into bracket x minus 1 all squared. So now you can see that at the denominator we have x, which is just linear factor without repeated, and this one is what is linear factor, that is repeated linear factor. So now for this one now, so we are going to have a over, that is the corresponding partial fractions of this x will be a over x, that is attached to a constant, plus b over, look at this one, this is repeated, therefore we are going to 2, so x minus 1, then plus c into bracket what? X minus 1 all squared. Can you see that? You can see for the first one, we understand that is 1, so we attach it with what? With a constant. Then also with what? The second one, which is what? Which is the last, because we are going to 2, because the power is 2, so therefore we attach this to what? To another constant, c. So where a, b, c are the constants to what? To solve for. So we are going to solve for a, b, and c. You understand? So whatever we now got for these values of a and b, c, and so we now try to put it back into this equation, then that is what does, it means our problem is solved already. So now from here, so let's say we come from here, we try to get the LCM. The LCM of this one will be x minus 1 all squared. So try to combine this as in put this one in a single, what's in a single fraction. So x, we take care of this one, that is x, we cancel this one, so we have a x minus 1 all squared, plus this one, we take care of one of this one, so we have b into bracket x, you understand, into remain 1 here, x minus 1. Then this, we take care of this, that is x minus 1 square, we have x minus 1 square, so we left with x. This x multiplied by c, we have cx. Are you getting what I'm doing? So try to write this one back: 2x squared plus 1 over x minus 1 all squared. So now from here, what's the next thing to do? So we are trying to make this one in a linear form by clearing the what? Clearing the fraction. So how do we clear the fraction here? Therefore, then we are going to multiply the denominator of both sides by the LCM, understand? So and the LCM is this and this. So now multiplying this by the both sides, definitely, So we are going to have 2x squared plus 1 equals to a x minus 1 squared plus b into bracket x minus 1. Are you getting it? Then plus cx. So therefore you can see that we have our equation to be in a linear form, that is, we have already cleared the fraction. So now the next thing to do, so we label this to be equation what? Equation star. So now from this equation now, so what do we do now? So we will now be testing, you understand? We do test here. We want to use cover up rule here. We can use cover up rule, we can use comparison method by equating the coefficients of the what's it called, variable that we have there. But here, so the cover up rule is the shortest way of solving this kind of problem. So now, how do we use cover up rule? So cover up rule is that you will be putting the value of x, you put the value of x, any value of x, that when you put it in this equation star, understand, so it will make some of the terms be what will be 0, so that you'll be left with terms that have one of the constant, then you solve. So what I'm trying to say, so we are going to do it now. So let's say I put x equals to 1. So now from here now, if x equals to 1 in this, that is, put x over in star. If you put x equals to 1 in this star, so what will happen? You can see we have 2, 1 squared plus 1 equals to 8. So in order not to waste much of our time here, you can see that here we have what? If you put 1 here, 1 minus 1 is 0, that everything will be 0 here. Plus, if you put x equals to 1 here, you can see that we have what? We have 1 minus 1, which is 0, so everything will be what? Everything will be 0 here. Then if you put x equals to 1 here, so we have c times 1, we have c. Can you see that? So now from here, so from here we can see that 0 plus 0 plus c, so everything will be c here. So we have our c to be equals to 2 times this, we have 2 plus what? Plus 1, which is equal to 3. You can see that we have what? We have c to be what? To be equals to 3. Are you getting it now? So the next one, so we still come back to this star equation star. We look for the values of x again, that when we put the value of x, which will also give us this same pattern. So now let's say I said my x to be, if my x is 0 here, that is, put x equals to 0 in what? In equation star. That is, if you put x equal to 0 in equation star, that is 2, 0, can you see, plus 1 equals to, here you can see, if you put 0 here, so we have a into brackets minus 1 whole square, because we have 0 here, then plus everything here. If you put 0 here, you can see that everything will turn to 0. If you put 0 here, 0 times everything here, you have 0. B times 0, we have what? We have 0. So if you put 0 here, 6 multiplied by 0, we have what? We have 0. So therefore, this one also will be 0 plus 1 equals to, we have what? We have a, because minus 1 square will give us 1. 1 multiplied by here, we have a. Then this one is 0. Automatically, we have our a also, it to be 1. Are you getting it? So you can see out of the 3 constants we are looking for, we have already gotten the 2 of them. So we have a equals to 1, now we have c equals to 3. So the next thing to do is to get the value of what? The value of c, that is constant O, constant b. So now, so what are we going to do now to get constant b? So this same area, so we are now going to move further towards to the second method, that is by comparing the coefficients, understand, of what? Of any of these, where we can actually get the value of b. So now we are now trying to, we come back to this equation again. So we now try to open the bracket, open the equation what? Equation 3, that is, we expand it. So we are going to have 2x squared plus 1 equals to a. If you open this one, you are going to have s squared minus what? Minus 2x, understand, plus 1 plus b into brackets. Here you are going to have s squared, x times this one minus what? Minus x, then plus cx. So now this is what this, when you open it, we still have 2s squared plus 1. You can see that a times you have as squared minus 2ax, then plus what? Plus a plus b what? Bx squared, because when you use b to open, then we have bx plus cx. So now what's the next thing to do? So we want to compare, and we are looking for what? We are looking for b. So look at this side, you understand? So bring out the coefficient. You can see, look at this one, we have s squared, so we have s squared there. Can you see that? Then we have 2s squared there. So if you try to equate, you know, equate the coefficient of what? Of s squared. So this is comparison method. So to equate the coefficients of what? S squared. So from the left hand side here, we have our coefficient of s squared to be 2 to be equals to the coefficient of s squared here. We jump towards to the other side, which is right hand side. So the coefficient of s squared is what? Is a. Then the coefficient of s, we have b. Can you see that? So that is all. So now from here, we are looking for what? We are looking for b. So, and we've already gotten, let's say, let's call this one starter. So we've already gotten our a. So what is my a? Our a is what? Is 1. So from here you have 2 to be 1 plus b. Are you getting it? So from there you have b to be equals to 2 minus what? 2 minus 1, which is equal to 1. Therefore, you can see we take this b 1 to the other side. I get it, so that we have b. So b equals to 1. You can see that my a is what? Is 1, b is 1, and c equals to 3. So we've already gotten all the constant now. So the next thing to do is to come here. So now coming to this equation, that is the first line of our solution, of our solving. So you put the values of a and b. So therefore from here you can see a. What is my a? My a is 1. You clean it, I put what? I put 1. So now look at the b. So what is my b? B is 1. So you clean the b, understand, where you write what? 1. So what is my c? The c is 3. Then we have this. So we put what? We put 3 there. Are you getting it? So, and that's what? That is how we solve that. Understand? So if you have any question, kindly ask. Hit the comment box and ask your question, and at the same time to check whether you are right or not. So if you try to solve this one further, you take the LCM and you make it a single fraction. So definitely you must arrive to this, or to this left hand side. That is, you must arrive to the equation and say to the question given to you. Are you getting what I'm saying? So that will be the end of today's lecture. So if you have not subscribed to my YouTube channel, try to do, and hit the bell to get the notifications anytime I drop my videos.